There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, and protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and solarium, and bismuth, lithium, beryllium, and barium. Isn't that interesting? I hope you're all paying attention. There's going to be a short quiz later on. There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercury and molybdenum and magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, radenzine, and zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.
Okay, everybody. I've got some concentrated hydrochloric acid in this water bottle here. And I have a shell. Now, we know that shells contain calcium carbonate. I'm going to carefully put this in. And I'm going to put the top on loosely. Start the timer. You can see the reaction going very quickly because the carbon dioxide is coming off.
The top timer's the one.
And you can see the carbon dioxide is coming off. And slowly but surely, the mass is going to get lighter and lighter.
Okay, it's 20.7, 120.7, 20.6, and 120.5, it's going down very quickly. We've got to be careful. This is something you don't want to do without adult supervision. Now you can do this with vinegar, but it would be much slower because vinegar is very dilute acetic acid. It's a weak acid in water. This is hydrochloric acid, and it's for use for pools. Okay, we're already down to 119.7. Yeah, you just put a little bit in to get the pH to be at the right value. The shell is kind of floating on the top. Okay, for some reason. Maybe there's some air underneath it. Okay, but the bubbles are getting off. All right, we're down to 119.4.
Now, as this reaction goes, of course, the hydrochloric acid concentration goes down because you're reacting the hydrochloric acid with this calcium carbonate, and that produces calcium chloride, which is soluble in water and carbon dioxide.
We're down to 119.2. Reaction, the shell is practically dissolved. I'm going to give it a little swirl.
This is why it's a good thing that you are not the cell. You are not a
now
cell.
This would be
then every time that's
extreme acid rain.
Extreme acid rain. And practically completely dissolve the shell in water. In acid, it wouldn't dissolve in water. And in vinegar, it would dissolve much more slowly. The shell is almost completely dissolved at this point.
So we have calcium carbonate
We said almost.
plus 2 HCl yields calcium chloride plus water plus carbon dioxide. Okay, so this is the chemical reaction that is occurring. I'll show you in a second.
Now.
Okay, this is the chemical reaction that occurred. Calcium carbonate, which is the main ingredient of the shell, plus 2 hydrochloric acid molecules react to form calcium chloride plus water plus carbon dioxide, and the weight loss is due to the carbon dioxide that came off. Okay, so it's about 5 minutes, and the mass is down to 118.7. Thank you for your attention.